Hi guys, today we're going to be looking at polygons. So we're going to be talking about what a polygon is and looking at the interior and the exterior angles and the formulas that we're going to use. So a polygon is a 2D shape with straight lines. So a polygon, these are corners. These corners here are called vertices. One of it is called a vertex. Now when we look at this, the line segments here are called the sides. So a polygon is a 2D shape with at least 3 sides. So when we look at this two shapes, they're regular polygons. So these regular polygons, this is called an equilateral triangle, and then this one is called a square. So in an equilateral triangle, we know that all the sides are equal because we've got these lines, and then the angles must be equal to 180 degrees, because each of these angles will be 60 degrees, 60 degrees, and then 60 degrees. A square is 360 degrees. So each of these corners is 90 degrees. So if I split this square into two, I'm going to get two triangles. So each of the triangles will sum up to 180 degrees, and this one will sum up to 180 degrees. So if we've got a pentagon has got 5 sides. So if we draw a pentagon, we'll find out that a pentagon can be split into 3 triangles. Now if we've got a hexagon can be split into 4 triangles. Each of the triangles will sum up to 180 degrees. So if we've got a heptagon which has got 7 sides, it will be split into 5 triangles. Now we look at octagon. Octagon will be split into 6 triangles. A nonagon will be split into 7 triangles, and a decagon will be split into 8 triangles. So, formula for calculating the size of an exterior and interior angles. Now let's look at the exterior angles. Exterior angles of a polygon is equal to 360 divided by the number of sides. So we're going to be looking at some examples. So if we've got a hexagon, for example, we're going to do 360 divided by 6, which is the number of sides, and that will give us 60. Now we look at the sum of interior angles. So this is the formula for the sum of interior angles. So let's give an example. In a hexagon, we've got a hexagon has got 6 sides. Minus 2 multiplied by 180 degrees. So we got 4 times 180 degrees. That will give us 720 degrees. Now to find the size of one interior angle, we're going to do 720 divided by 6, which will give us 120 degrees. But to find the exterior angle of a polygon, that would be, for example, the hexagon would be 360 divided by 6, which will give me 60 degrees. Now, the size the size, remember that the interior and exterior angle add up to 180 degrees. So let's say we've got this, and then this is 60 degrees. This will also be 120 degrees. So the interior and exterior angle add up to 180 degrees. So we're going to be looking into some exam styled questions, and then you understand it better. We're going to look at this question. So the size of each interior angle in a regular polygon is 20 degrees. Size of each exterior angle. So we're going to work out how many sides this polygon has. Right, so what we do, because it's exterior angle, remember what I said about exterior angle of a polygon is 360 divided by the number of sides. So we've got 360 divided by 20. Okay, we're going to cancel out these zeros. We're left with 36 divided by 2, which will give us 18. So this polygon has got 18 sides. We move to the next one. The size of each exterior angle in a regular polygon is 18 degrees. Work out how many sides the polygon has. So what we're going to do, just like we did for the other one, we're going to the 360 divided by 18. Now we're going to half this one. If we half it, we get 180. Half this one, we get 9. So 180 divided by 9 is going to give me 20. Now the next one is a bit different from the one we've done, the first two that we did. So we're going to look at this one now. The size of each interior angle in a regular polygon is 165 degrees. Now we're going to work out how many sides the polygon has. The size of each interior angle. So what we're going to do now is 165. We're going to take that away from 180 to give us 15 degrees. So this is the exterior angle. So next we have to find out how many sides the polygon has. So that's 360 divided by 15. We're going to look for a number that can go into 360 and 15. So we can divide this by 3 and divide this by 3. So this will give us 120 over 5. So if you divide 120 by 5, you're going to get 24. I've got another question that says A, B, C, D, E, and F is a regular hexagon. So E, F, G, H is a square. E, F, G, H is a square. Okay, so we're going to work out the value of X. So first of all, we know that this is a hexagon which has got 6 sides. So we find the exterior angle of this one. So exterior angle of a hexagon is 360 divided by 6. That will give me 60 degrees. So here is 60 degrees. Now this is a square. To find the exterior angle of a square, we do 360 divided by 4. That will give me 90 degrees. So this bit here is 90 degrees. Now to find X, to find x would be 60 degrees plus 90 degrees. That will give me 150 degrees. So from here to here is 150 degrees. Next question is, the diagram shows 3 regular pentagons meeting at a point. 3 regular pentagons. So the 3 of them are pentagons. So we're going to work out the size of the angle marked X. So first of all, the exterior angle of a polygon of a pentagon is equal to 360 divided by 5, which will give me 72 degrees. Now we look for the interior angle of a regular pentagon. That will give me 180, take away 72, will give me 108 degrees. Now, because we've got 3 pentagons, 3 regular pentagons, we're going to multiply 3 by 108. That will give us 324. And then 360, because it says meeting at a point. So angle at a point is 360 degrees. So 360 degrees, take away 324. That will give me 36. So my answer to this question is 36 degrees. Our next question is this one. It's a bit complicated, but I'm going to show you how to do this. So the diagram shows a regular pentagon, ABCDE, and a square EDFG. So the lines CD and DG are both sides of another regular pentagon, which is P. So how many sides does polygon P have? And then you must show how you got your answer. So the first we're going to do is to start with the polygon. The regular pentagon, sorry, I always say polygon. The regular pentagon. So the regular pentagon exterior angle is 360 divided by 5, which will give us 72 degrees. Now we get the interior. Remember I said interior and exterior add up to give you 180 degrees. So we've got 180 degrees, take away 72, that will give us 108. Now we're going to look for the interior angle of this polygon P. So the interior angle of the polygon P would be 360, take away 90, because we've got 90 degrees and we've got 108, because the 90 degrees is here and 108 is here. 90 degrees. So 90, take away 90, take away 108, that would give us 162. So we're going to find the exterior angle of this polygon P. So that would be 180, we take away 162, that would give us 18. So 360 degrees divided by 18 will give us 20. So this polygon P has got 20 sides. Okay, let's do this last question. All right, we've got shape A is a regular triangle, which means each of the inner angle should be 60 degrees. So this is 60 degrees for each angle of a regular triangle, which means it's an equilateral triangle. So we got shape B, which is a regular octagon. So we're going to find the interior angle of this triangle is 60, just like I've told you, and the exterior angle of this polygon, this octagon, regular octagon, is going to be 360 divided by 8. Remember, it's exterior angle, which will give me 45 degrees. Now interior, I'm going to find the interior angle of this octagon. So interior would be 180, you take away 45, that will give you 135 degrees. So now to find the interior angle of polygon P, interior angle of polygon P, we're going to do 360 take away 60 degrees, take away 135, that will give us 165 degrees. This is interior. We look for exterior angle of P, that will be 180, take away 165, which will give me 15 degrees. Now 360 divided by 15, we got 125, which will give 24. So this polygon P have got 24 sides. So it's the same method for working out all of these questions, the interior angle and the exterior angle. All right, I'm going to stop here now. I hope this video helps in finding the interior and exterior angles of a regular polygon. Bye.